Okay, let's say that I have this function, y equals x times the square root of 4 minus x squared. And I want to find the area from -2 to 2. Well, typically, if you're in a calculus class, you find the integral from -2 to 2, that's the interval that I said I wanted to find, of my function. If you work all of this out, you get 0. The reason why is if you would actually look at the graph of this function, what's happening is you have some area that's under the curve that's symmetric with the area above the curve, and so this negative area is canceling that positive area out. Not a problem. Because it's symmetric, you can just find the area of either piece and then you can double it. Of course, this piece you'd have to absolute value it. However, it's good to kind of have a side note. What if the area is not, what if this is not symmetric? Like, in other words, what if this went out to 3? Then all you would do is divide this up and say, let's go from -2 to 0, absolute value that, plus let's go from 0 to 2, and then when you add those two together, you're absolute valuing, and then this area, you get the actual area. All right, but because I know this is symmetric, then I know I can just find either one and double it. So let's do that over here. Doesn't matter which one, I don't feel like writing absolute value bars over and over and over. So let's do the 0 to 2. And then my function, which is x times 4 minus x squared, and then my width. Remember, that's just the width piece. Now, I tell students when you're first learning to do substitution, I kind of change up the order here. All of this is being multiplied, and you're going to see why. I have a reason for doing this. All right, first of all, how do I know this is substitution? Well, I have one function times another function, so that's key right there. A lot of times with substitution, what you're going to substitute, typically what's under a square root, and that's what I'm going to use. Could be something exponential, could be something in parentheses to a power, could be a denominator. Those are the things that you're looking for. All right, so when I say substitution, that means where I see 4 minus x squared, I'm going to put in a u. All right, that's all and fine, but the problem is now this is with respect to a different variable, so this has to become something that has a du in it, okay? In a perfect world, if I could just make that du, everything would be good. So let's kind of over here to the side say let u equal 4 minus x squared. I'm going to take the derivative of this function with respect to x. So the derivative of 4, just 0, right? Constant. Negative sign. Bring the 2 down. Subtract 1 from the exponent. And now what's kind of cool here is you can actually treat this like a fraction. I can multiply dx on both sides, and I get this, which looks pretty darn good, because if I go back up here, that's that piece. But the problem is that stinking -2. Not a problem. I can just simply use my algebra skills and divide that off of both sides, and I get my x dx. Now, I kind of do this extra step because you're going to see why. I like to throw any of my values out front, and so then over here I have my x dx. So I can see now up here where I see x dx, I'm going to plug in -1/2 du. All right, we're okay. Take a deep breath. Pretty good so far, right? So I just continue with this and I start doing substitution. I, again, like to throw any constants out front, so I'm going to put the -1/2 out front. I still have my integral here from 0 to 2. Where I see a 4 minus x squared, I'm going to replace it with a u, and I'm going to go ahead and do another step. Remember, the square root is the same thing as the 1/2 power. That way it'll make it easy to do my antiderivative. And then don't forget your du, which makes sense now because these variables have to match. So from here, you remember integration, you remember antiderivatives, right? Right. So how do you find the antiderivative of a power? You take and you add 1, top and bottom. And so moving right along, over here I have my negative 1/2. Let's call that 1 a 2 over 2. So that becomes u to the 3/2 over 3/2 on the bottom. If I flip, okay, because fractions, when you divide, you flip and multiply, the 2's are going to cancel and you're going to be left with a negative 1/3. Where I see u, let's go ahead and put u back in, which is 4 minus x squared. And please don't forget that 3/2 power. All right, so now I'm to the point that I can evaluate this from 0 to 2. Okay, so that's actually every step here, but I'm lazy and I don't like to write it. So if I evaluate this integral, how am I going to do it? I'm going to throw the negative 1/3 out front. Inside here, I'm going to do my 4 minus up top here 2 squared to the 3/2 power minus, because I'm doing my integral, okay, my f of b minus my f of a, 4 minus now my 0 squared to the 3/2 power. All right, so in this case I have negative 1/3, making sure I'm still on the board. 2 squared is 4, 4 minus 4 is 0, so that piece goes away. Don't lose that negative sign. And so here I have this negative. Inside here I have 4 to the 3/2 power. Do you remember what to do with that? Where can I write this? How about right here? So 4 to the 3/2 power means the square root, that's the little 2, 4 cubed, 64 times 4 is 16, 16 times 4 is 64, square root, so this would be 8. So over here, this becomes 8. A negative and a negative become a positive 8/3. And I say, woohoo, I'm done. And I say, oh, no, you're not. All you did was find, where's my graph? This area right here. So this area is 8/3. Guess what this area is? Negative 8/3, but I'm going to absolute value it. So let's add the other 8/3. And hopefully you remember how to add fractions. Haha, that was humor. And you get the total area as a fraction.